Hi there, welcome to another edition of Varus DesignSpark's Ask the Expert. Today we're going to be talking about network testing. I've got Fluke Networks and I've got Nigel Hedges from Fluke. Hi Nigel, welcome to DesignSpark.
Good morning, Greg. Lovely to be here.
Fantastic. Nigel, as I said, we're going to be talking about network testing. Obviously, a very important area in today's environment, both for industry and commercial communications, for example. So what is it that we're looking at in sort of the fundamental components of cable networks, and why is it really important in modern day data communications, for example?
Well, I think it's probably fair to say that there is no such thing as a business, indeed a home these days, that doesn't communicate. Uh, Businesses communicate their product, their offerings, then their invoices, then their delivery notes. All of those things have to be communicated both within and without the company, as uh, largely are personal communications between human beings, between families, between friends, even between enemies, and in some cases between unknowns. And all of those communications have to pass through a network of some form. Historically, the networks were always wired or cabled. These days, we have copper cable in the network, we have optical fiber in the network, and of course, these days, we also have Wi Fi. And all three of those things work together to provide us with those links that connect us to the rest of humanity, if you like. Um, and all of those um, components of the network, both active and passive, active being wireless access points and switches and various other electronic devices, and the passive componentry, the wires, the optical fibers, have to work together and provide the necessary bandwidth so that when we
Mm.
Google something, we get an answer swiftly without waiting ages for it. Latency is an enemy. So there's a lot of efficiency built into what we're installing today to carry that communications burden. And certainly where the vast majority of networks are concerned, copper twisted pair cable is the primary carrier when it comes toward the human being, if you like. And the available bandwidth, the performance of that copper cable can be crucial to getting the type of speed that we want.
Yeah, I mean, obviously through your summary there, in terms of the level of communication, you were talking about um, latency. I just want to come across some of the common issues that are encountered during installation. For example, we're talking about communication delivering a lot of data, but why should we pay heed to the things like cable quality and then talking about proper terminations and then obviously interference being a factor? Can you just express some of the issues that could be encountered during the installation process and maybe things to avoid?
When we're looking for significant amounts of available bandwidth, so when we want to transmit large quantities of data, either between uh, network and human or network to network, we're concerned with the quality of the cable installation. The available bandwidth is dependent on how the cable, to a certain extent, how the cable itself is treated, and then more importantly, how it's terminated. So how the
Yeah.
cable is handled literally in the last, let's say, foot or meter, while the cable is being laid into tray or uh, let's not talk about buried underground, but laid into tray or put into a building, how it is maneuvered, and then how that last, let's say, 6 inches of the cable is handled when we're putting the connector on the end can be crucial to the way it performs. Typically, what we see is noise and reflection occurring at the termination points, and that is down to inadequate termination practice. One of the things that Fluke Networks has built a business on very much is proving or confirming that the installation has been carried out correctly and that the cable is going to deliver the bandwidth, the distance, and the signal strength to support the applications that the user wants to use. I mean, it's probably fair to say that today most users are sitting at the end of a 100 megabit or a gigabit network connection if they're talking about a PC or a device like that. Within data centers these days, we are talking about 10 gigabit per second data transmission, 100 gigabit per second data transmission, although not usually on copper, but on fiber. And all of those transmission lanes have to be tested, because that's the only way we know that errors were not made in installation. Certainly, Fluke Networks has built a very significant business out of the certification end of that requirement. Some of the products that we talk about address a less demanding area, and I guess we'll come on to those in a moment or two.
I've seen countless times, people relying on really bad termination points with cable, and then wondering why the actual installation is suffering. So, in terms of those best practices, absolutely right. Give thought to the proper termination that you need to make with cables and connectors. Also, give thought to the actual proper tooling that you use. And these are the things which are going to provide ultimately the optimal performance and longevity of that installation. It's interesting to hear you mention about the last meter being really important, and obviously, how we actually deal with that. And I just want to move on to a little bit more about best practice, but I want to understand a little bit more about the industry standards and guidelines during installation. What is it that we are looking at, and why are they so important, do you think?
Certainly, they provide us with a very precise series of installation guidelines, standards, limits of performance to reach a required level or to support a particular application. The most commonly referenced limits in the cable industry certainly are the US-based TIA, that's the Telecommunications Industry Association industry standard, which is referenced 568 and is currently in its ABCDE variant for both copper, twisted pair, and fiber. In the rest of the world, we have the ISO, the International Standards Organization, and though the relevant standard is based in ISO 11801, once again covers both copper and fiber installation, maintenance, and operation. There are a plethora of other standards which provide specific detail associated with those. In Europe and the UK, we also often reference EN, the European norm, which is fundamentally a cut and paste of the ISO standard. It actually currently has some slightly tighter specification in it than the ISO standard does, but generally speaking, they are mirror images of one another. And those are the three. I mean, there are many, many other standards. We have also application standards. So there is a published specification for gigabit Ethernet, for instance, which is a very specific set of numbers. which is less demanding than the ISO or the EN equivalent. So one of the safety factors, I guess we could say, is that both the TIA 568 and the ISO 11801 standard provide us with some additional performance over that required by the fastest application standard relevant. So
Right.
currently the fastest or the widest bandwidth application standard for twisted pair is 10 gigabit per second Ethernet. And that is covered by, in TIA terms, the category 6A installation cable and installation standard, or in ISO terms, the class EA. They're basically equivalent to one another. And then we step downwards from there. And it really depends what the application requires. The application requirement will be dependent on the hardware that's being used. So
Yeah.
different devices will have different requirements. And we may choose to change the cable type to match the device. So for instance, if we're talking about a CCTV camera, typically they require perhaps up to a gigabit of bandwidth, in which case we can use a category 5E or a category 6 cable. We don't really need a category 6A cable to transmit the data for that camera. If we were talking about transmitting large quantities of data between two switches and we were going to use copper, we would typically go for Cat6A because that gives us the maximum copper bandwidth, 10 gigabit per second required. One area which is a relatively recent development is the addition of power to the data stream. So currently we're running up to 10 gigabit per second in each direction over a twisted pair cable. And typically these days, one end of that transmission reception will be a switch. The other end may be a device, let's call it a field device, maybe a camera, maybe a wireless access point, maybe a door controller or a biometric scanner, and we may want to power that remote device over the same cable.
Yeah.
It saves us from having to put mains supply at the remote point, and it means that we can run data and power simultaneously over the same cable. So the requirements of the power over Ethernet remote powering requirement are added to the data transmission requirement. So we get more stuff happening in the cable, and the installation practice needs to be, again, better, because we need to make sure that we're controlling resistance as well as impedance, near-end crosstalk, noise, reflectance, otherwise known as return loss, within that cable structure. And the only way to know whether we've done it right is to test it.
Nigel, obviously, with Fluke, you have a whole host of test equipment, really reliable products, year after year after year. But I'm really interested to find out more about the new LinkIQ Duo for network testing. So you've introduced this. The emphasis is all about, dual functionality for both cable and Wi-Fi testing. Could you just give me a little bit more insight into this device and why, it's going to add lots of value to anybody within network testing?
Very happy to. I can, in fact, show you one. This is a LinkIQ Duo. LinkIQ Duo is a development of a product that we've had for a couple of years now, which was called LinkIQ. The Duo bit adds to the existing copper twisted pair network and power over Ethernet testing, adds Wi-Fi testing. So we have the ability now to interrogate the wireless environment around us and look
Mm.
at what networks are there, what interference may be happening, what the security level is of each access point, which radios are operating, which bandwidths they're in. All of these things can impact the efficiency of transmission of data. And we're back to that timely delivery of data is crucial. 10 years ago, if we wanted to know how Granny was, we'd either pick up the phone and ask somebody, or we'd write a letter. These days, we send a
Mm.
WhatsApp and we expect an answer in 20 seconds. In order to make that happen, we need the network to be up, running, and fast all the time. So LinkIQ Duo is very much our latest product. Yes, it's a recent addition to the range. We launched it end of 2024, and it really is proving to deliver some very fast, easy capability when it comes to testing the copper links that support our network, to confirming the availability of network resource, the
Mm-hmm.
availability of power on the same cable, and then also to look at what's happening in the Wi-Fi, what might be interfering with our Wi-Fi device. Now, what we have endeavored to do with LinkIQ Duo is to provide a catch-all tool for not only installers, but also network operators, maintenance people, technicians, people who are not necessarily experts in any of these environments, but who are people who are called upon to answer questions
Mm-hmm.
about the network. You know, the classic user question, why can't I connect? And the short answer is, well, let's have a quick look. We can connect, so it's not the network. And that has to be a fundamental answer. It's not the network, it's not us, it's you. Now, in some
Yeah.
cases, the poor IT guy is going to get called upon to work out what the you is, but that's kind of a different issue to it's first, let's answer that, let's confirm that it's not the network. So
Yeah.
LinkIQ Duo has usable, accurate, reliable data delivery when it comes to um, network, Wi-Fi, and the cable as well. We also have an extension which we've just launched, which enables it to measure received power over an optical fiber link. So we're adding to the capability
Right.
as we go along.
That sounds really great. In terms of, you have your wired network, your Wi-Fi, when you put an additional access point, retesting, etc. So really, you have a unit now which can do all of those processes. I was really interested in something you just said about the actual use of the product. If it's, we're talking about network professionals and installers, but then also, as we were talking about, maybe some network maintenance. So I just want to understand a little bit more about how does the Link IQ Duo simplify testing to troubleshoot, for example.
That's a really good question, and it goes back to the expectation of the network. Different networks will have different expectations, different network componentry will have different requirements. So, for instance, let's go back to our CCTV camera. With the CCTV camera, we're going to install it, or we are installing it on the end of a piece of cable which is already in the building. We may be reusing a cable, or we may be using a freshly installed cable. But what we need to know is, does the cable have sufficient bandwidth to support the gigabit network connection which the camera requires? first question. So LinkIQ Duo can run a test which uses frequency-based measurement to determine whether or not there is sufficient bandwidth to support 1 gigabit, 2.5, 5, or 10 gigabits per second Ethernet transmission. At the same time, we can also confirm that the length of the cable is within specification, that the noise characteristics of the cable are within allowances, and we can then move on to having tested the cable and confirmed its bandwidth, we can then plug it in at the switch end, and going back to the camera end, we can confirm that we have network connectivity. We can see the switch. The switch responds to a query from LinkIQ, and we can also confirm that the switch is delivering the required amount of power over Ethernet. And we get clear, unequivocal test result data that shows all of that. And then we hang our camera on the end of it, and we have a valid connection back to the switch and then into the control software for the camera. But fundamentally, we have to know that we have acceptable cable of an acceptable length with the available power and network connectivity on it. And that's really what LinkIQ does. It enables us to confirm all of those details as we go along. Bearing in mind, of course, that where power over Ethernet is concerned, the power over Ethernet availability today might be different tomorrow because of additional devices connected to the same switch. So switches have a limited amount of power over Ethernet available, and if you keep adding devices, eventually something falls off the end. So what was available yesterday, always assuming we haven't changed anything, should also be available today. Confirmation, again, test to confirm. Can't rely, if you plug the camera in and it doesn't light up, there are a number of different things it might be. So we need to do the testing to know.
Nigel, that's an interesting point that you make about obviously the test, but then obviously if something else has been, for example, a retrofit or an addition, then that testing obviously you can then perform through the Link Duo IQ, and you could do some pre-test before you actually then start to upgrade the system if you like. Is that correct?
Absolutely. And if for the sake of argument, typically what tends to happen is CCTV cameras are either left alone for 10 years or 15 years and never touched because they're working fine, or like a lot of other network equipment, they get replaced every 3 or 4 or 5 years. And the upgrade is almost better than the one that is being replaced. So we might go from a black and white fixed lens camera to a color variable lens pan, tilt, and zoom camera. If it's fitted outdoors, it might have a heated lens. And all of a sudden, you go from a 15-watt power requirement for the black and white to multiple power requirements in order to operate the pan, tilt, and zoom, the color, and the infrared, and an additional power supply required to heat the lens. So hanging it onto the same cable is absolutely feasible, provided that the power is also available to do the job. And that means reconfiguring the switch to deliver potentially 2 different sets of power over the same cable, and also handling the data transmission from the camera, which probably increased by a factor of several. So wireless access points also exactly the same. One of the things that we are always conscious of is that the installed cable rapidly becomes the oldest part of the network, because the active component, the switches, the decked telephones, the laptop PCs that people are using, the devices that hang on the end, get upgraded at a considerably faster rate than the
Mm.
cable, be it copper or fiber, because it's so difficult to get at. Once it's installed, it's hidden behind containment or trunking or conduit. Um, in some cases, other things get built over the top of it, and replacing the cable becomes a significant issue. So knowing the
Yeah,
performance of the cable becomes more and more important as time goes by.
absolutely. Yeah, because obviously the added expense that then brings into the role of upgrade is so much more significant than the cost of the actual components, for example, that you're adding into the network. Um, so yeah, that point is definitely not lost on me or anybody who is seeing a lot of roadworks where cables are constantly seem to be dug up and overhauled, installed again. We can all testament to that in our personal lives as we drive around this country to some extent. Nigel, I just want to look at the Link Duo more around the key features. Is some applications or some functionality that you can share with us if we were to say, okay, show me the highlights?
So this is a cable test report or result, let's put it that way. And we can see at the top here, we have cable length, we have cable ID. This is a wire map indicator. And down at the bottom here, we have what we call the speedometer. And the speedometer is graduated from 10 megabit per second, which these days is dead slow, to 10 gigabit per second Ethernet. And this is our bandwidth confirmation. In this particular case, we are green all the way to 10 gigabit. So we have full capability to provide support for a 10 gigabit Ethernet transmission. Now, these days, the field devices that are using 10 gigabit are relatively few and far between. We're starting to see them roll out with the arrival of Wi-Fi 6 and Wi-Fi 7, where we are starting to transmit huge quantities of data over the Wi-Fi in the Wi-Fi environment. Let me get out of there for a moment, and before I show you the Wi-Fi, let me take you to this screen, which is our network connectivity screen. And this is the second step. I said first we test the cable, then we test the network connection. And on this screen, we would see the connection to the switch, the speed of the connection, the duplex settings at the switch, the IP address of the switch, the DHCP, Dynamic Host Control Protocol data, which is allowing the communication between LinkIQ and the switch, and the VLAN data. VLANs, virtual local area networks, are where how we divide up the various different tasks required of the network. And then if I slide upwards, once again we have the wire map display, and then underneath it, two different power over Ethernet tests. One of them is basically we query the switch. We say to the switch, hey, switch, how much power are you giving this link? And the switch responds and says, I'm giving class 3, which is understood. And then we apply a load to the cable and make sure that the switch is actually delivering what they say they're delivering. And then the second test down here is not so much, hey, switch, what are you giving? It's, okay, what could you give if we asked? and we get a second test result in a lot of cases, always assuming the switch has more power to give, that confirms what is actually available. And from that, we can confirm, yes, I have good cable, yes, I have a valid network connection, and yes, I have sufficient power to hang the access point that I want to hang on this, on the end of this cable. And then once we have that, we can investigate the wireless environment. We can look at the networks available where we're installing the access point. One of the things with Wi-Fi and wireless networking is it is a movable feast. So you have multiple wireless access points potentially supporting multiple different networks. Taken as an example, a typical shopping center. You can have Next and Morrison's and probably not Tesco, but Primark and Marks and Spencer's all have their own networks in the same environment, and all of them will intersect with one another. And then you probably have the shopping center overlay, which is the one you use when you're walking between shops, and all of them potentially can interfere with one another. They all have to share the same 3 sets of bandwidth, so 2.4, 5, and 6 gigahertz. They all have to recognize that there are a limited number of channels available, and that security may be crucial. I don't think any of the retailers want their customers getting into their corporate network. That's what happens when you get ransomware demands and that kind of thing. So we definitely don't want that. So security settings are crucial. We need to know that that the security is at the latest limit. So one of the things that we sense as part of the whole network checking environment, which I'll show you live in a moment, is very much what is the security level, what is the signal strength, and how many access points can we see, how many radios are active. Because, of course, an access point can contain multiple radios operating in different wavelengths in order to provide the maximum amount of data transmission capability. So there's an awful lot that happens, that goes on when it comes to Wi-Fi. It is both the most ubiquitous type of network that we see today in our daily lives. I guess most of us have Wi-Fi at home, and our next door neighbors also have Wi-Fi, and potentially there is interference between them. And that is both most convenient, but potentially also most vulnerable. And we need to take account of both of those at the same time. So yeah, there's a huge amount of data capability available. Let me just have a quick look. Yeah, I don't know how this is going to show on the screen, Greg, but this is This is the network list from my home network. So at the top of the list is my own home network. You can see there is a signal strength indicator. The security indicator is immediately below that. The different types of Wi-Fi network are shown across there. And on the right-hand side, a Wi-Fi radio counter. So my own network is running 2 radios. It's running Web3 security, and I have 5 different types of Wi-Fi standard available on my own network. Actually, interestingly, that's my next door neighbour's network. I have to go and have a word with him about that because he's got 10 radios. He's just greedy. He has an extended network. Let's just leave it at that. I'm happy if I can get Wi-Fi in my office. He wants it in his garage, and goodness only knows where else.
Yeah.
So there's a huge amount going on, but equally, let me also just show you this one. This is the let's go there. This is a display of the 2.4 gigahertz network. 2.4 gigahertz bandwidth. And each dot that you see on the screen is an access point. Where there are numbers associated with the dots, that means there's more than one access point. And what we have is signal strength, up that side of the screen. So the higher the dot, the stronger the signal. And the pale blue is an indication of utilization per channel. So for instance, this left-hand bar is channel 1, which is probably one of the most commonly ones used in domestic environments. You can see multiple different access points. Mine should be the strongest one, but you can see multiple access points, and the horizontal line indicates where that access point is transmitting across channels. And all access points do, because the channels are 5 megahertz wide, but the transmission from each access point is at least 20 megahertz wide. So we center the access point in a particular channel, but it actually transmits a much wider thing. So we automatically get interference between adjacent channels. And interference means reduction in performance. Only one access point can transmit at a time. So everybody has to agree whose turn it is. It's like you and me talking, but with our wives and children in the room at the same time. Everybody has to wait their turn. And access points are exactly the same. Otherwise, access points on different networks will interfere with one another and reduce performance. Reduced performance equals latency or lost transmissions. That's when you have to send the same message twice in order to get one answer. So there's an awful lot of data in what we're looking at. There's an awful lot of, I really need to go talk to my next door neighbor and tell him to shift. He's currently transmitting on a channel that interferes with two of the cardinal channels in 2.4 gig. And it'd be really useful if he moved to one or the other rather than messing with the whole close. But that's as it is. There's a lot of data which is actionable, and that's the important thing with Wi-Fi is you need to have data which is actionable. You need to be able to say, I have an access point which doesn't have security on it, but it's connected to my network. I need to identify it, which we can do. We have an access point location capability, which is just purely based on signal strength. You hold the unit in front of you and you walk around, and if the signal strength gets stronger, you're going in the right direction. It works really well, although it sounds very simple. But you need to be able to identify the access points which are vulnerable, because vulnerability is dangerous. Not just from next door neighbors borrowing your Wi-Fi, but from the ability of corporations to be attacked, as we've seen recently with malware and ransomware attacks that are incredibly expensive and very difficult to manage. So it's
absolutely
it's a cool tool.
I think what the LinkIQ and what you've explained there has shown me is you've just kind of lifted the lid on the communications, what's actually happening, what's going on. Yeah, the point about the access points is not lost on me as well, because you you hear of people who are creating networks and have invested thousands of dollars or pounds into their network capability, lock down the security, and then inadvertently somebody adds another access point, but doesn't actually lock the access point down, so that becomes vulnerable as well. I think from what I've seen, this product really is, it's such a great product. But also that, as you're showing me through those screens, they're so easy to follow, and it's really a lot of thought's gone into the design of this product. And for me, it's just lifting that additional functionality, that overall network capability to include wired and wireless, for example. So that's really great. I just want to come back a little bit. So the product itself, absolutely fantastic. But in terms of the network and the communications, for example, I just want to go into maybe some of the things which users need to give credence to. For example, the regularity of testing. And you mentioned specifically there about the signal strength, for example, but also in terms of interference. And as you mentioned, with the cable network, that could be the oldest part of the system, and things around it change and the need for testing. So I just want to know, what it is that you would recommend in terms of things that we need to consider for the kind of the maintenance, the upkeep, the routine of regular testing, for example.
You make a very good point. I think one of the realities of the networking industry is that as long as a connection is working, the network administrator, the CIO, is never going to allow you to disconnect it for a routine test. As long as it works, don't touch. It's only when it stops working suddenly, and then it's, well, hell, the access point that normally works in dispatch isn't working. We can't send dispatch notes to the warehouse. We're losing X number of millions of dollars of invoiceable business every hour. RS Components operates in a huge business where this is, timely delivery is part of the business. How quickly can we fix it? Or do we need an alternative? Do we need a backup? All of the above things. And used to be that people would say, oh, we'll just put 2 access points in. But 2 access points may conflict with one another. So you have to be real careful putting 2 access points in the same place. But when you have something that fails, then that's an immediate opportunity to carry out whatever testing is relevant. So wireless access points stopped working. First test, is there power and is there connection to the network? So you pull the access point off the wall, you take the connector that was in the access point, you put it into the LinkIQ, and you hit auto test. And LinkIQ will go away. It'll say, I have a cable, I can see a connection to the network, or I can't. In which case, why is there no connection to the network? The cable's open. How long is the cable? If it's 6 feet long, 2 meters, then it's possible that you have a break at the end of the patch cord. If it's 100 meters long, then the break is probably, or the disconnect is probably at the switch. Okay, I fixed that. Now I have connectivity to the switch. The switch is on. I can see the switch. That means I have a good network connection, but I don't have power. Has somebody reconfigured the switch? Has somebody added something to the switch which has taken power away? So all of these are under pressure measurements that need to be made quickly. And that's where LinkIQ comes in. It's quick. Some people feel it's not as quick as they'd like it to be. That's mainly because they're under pressure, but it's quick. And
Yeah.
we get hopefully we get the right answers at a decent speed. When it comes to wireless or Wi-Fi, one of the challenges is that the Wi-Fi environment changes every second of every day. And one of the reasons it changes is that it operates at human level, so where people walk around. And unfortunately, human beings are filled with water, and therefore they're very good at absorbing Wi-Fi signals. So literally, a person walking down the Wi-Fi path can interrupt transmission of Wi-Fi from one point to another. And then they step out of the path, and all of a sudden your Wi-Fi is great again. And that is a challenge in itself, because you have to find ways. I mean, the other thing which fascinates me with Wi-Fi is that big warehouses tend to have Wi-Fi these days. They've got all sorts of robot-controlled devices and that kind of thing. When the Wi-Fi was installed 10 years ago, it was a level of Wi-Fi that was available at the time. And one of the things that tends to happen is people go, oh, well, we could go faster if we had better Wi-Fi in the warehouse. So we'll upgrade the Wi-Fi. So they take down all the old access points, they put up some nice new ones. But the new access points come in 2 or 3 different flavors. They may be now too close together because they are more powerful. They may alternatively leave gaps because we've gone from the 2.4 gig range to the 5 gig range. And 5 gigahertz has a shorter range capability than 2.4 gigahertz did. So we have to be careful when we upgrade Wi-Fi devices, not only in the warehouse, but anywhere, because we can change stuff. If we reposition, we can generate our own interference, human beings, horses, whatever's walking around and absorbing Wi-Fi energy. Modern Wi-Fi also uses multiple different paths to get from point A to point B, whereas the old style Wi-Fi used 1 or 2 paths. Current units can use multiple paths, which means theoretically less interference generally, but equally, if they're not positioned carefully, we get all kinds of other issues. So we have to take account of that as well when we look at Wi-Fi and look at testing, because, and particularly with twisted pair, we can reasonably expect that a test we run today and a test we run tomorrow and a test we run next year will be largely the same on the cable. The network may have changed because you may have replaced a switch or replaced a remote device and things change. But generally speaking, the cable itself will remain pretty much standard. If it changes, people have to ask why. What did you do? Did you change a patch cord? Because if you changed the patch cord, maybe you exceeded the maximum length allowance. Maximum length allowance, broadly speaking, Ethernet is designed around 100-meter maximum. I think that's pretty much well known. But there is some flex, some stretch included in that number. But Wi-Fi changes every time you move. One of the things that has happened, particularly with regard to Wi-Fi, is that we can get all kinds of data off our mobile phones, which is great, but it's not detailed. It's not reliable necessarily. And I advise caution when you look at the mobile phone, because even with all sorts of clever software on it, you don't get the kind of detail that is necessary if you're looking for a rogue access point or if you have interference, particularly if you hold your phone
Yeah.
like I do at belly height, and there are 3 or 4 people walking around you. Messes with the signal all the time. So mobile phones are great,
Yeah.
but a dedicated tool for testing is a superior solution. The other thing, of course, is that mobile phones don't test cable. So we really like the cable test capability together with what we have. Thank you very much for allowing me the opportunity to talk to you.